Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
With aggressive decarbonization goals, the electrification of everything, and increasing energy demands, utilities are facing some big challenges, including how to build out new infrastructure required to keep electricity flowing into the future. In this episode, I'll be talking with Phil VanSant, manager of T&D Services, System Protection at Dominion Energy, about how the utility has come up with an innovative way to construct and commission new digital substations in an efficient and cost-effective way. Phil has 18 years of utility industry experience in transmission system operations, system protection, and engineering standards. After 5 years with American Electric Power, Phil started working with Dominion Energy Virginia and has been part of several major efforts, including distributed energy resource interconnections, facility rating verification, and developing a new digital substation design that uses IEC 61850 and drop-in control house enclosure combinations. He has a BSEE from Virginia Tech and is a licensed professional engineer in the state of Virginia. Phil, thanks for taking the time to join us today, and let's get into this. How did you come to work in the electric industry?
So thanks, Dave. I appreciate you having me here today. Kind of interesting with my background. My grandfather was an electrician for a career, and my father was a substation technician for a cooperative in Virginia. So I got exposed to the electrical industry pretty early on in life. And I remember even as a 10-year-old on the front porch, my grandfather trying to explain Ohm's Law to me. So that was pretty neat. And, hanging around with my dad, going to work sometimes with him and doing some, bucket truck things and, some substation things was pretty cool to see.
So you were a kid in a bucket truck?
Well, they didn't let me go up in the bucket truck. They let me operate the controls from the ground one time. But
Could you do that today?
Probably not.
So you come by this honestly. Did you go into Virginia Tech knowing you wanted to be an electrical engineer, or did you kind of fall into it after you started?
So I went in for electrical engineering. So my parents, they really pushed us kids to get a college degree and get a career. So I was interested in electrical, was pretty decent in science and math. So got into the electrical track and came out with my degree in electrical. Started off working for American Electric Power in their system operations center. It was kind of interesting there too. I had choices between going to work for a utility or going to work for a defense contractor. And so there's a decision point there. The defense contractor had an 18-month wait to get the top secret clearance for the work I was going to be doing. And so just with the other things going on in life, I chose to take the utility job, and kind of history went from there. So
I kind of did the opposite. I started right out of school. I went and worked for a defense contractor, had a good time, and then I ended up back in the electric sector. So yeah, it's a small world. As I mentioned in the intro, you and the team at Dominion have designed and are building a new drop-in control enclosure that is streamlining the process of adding new modern substations within your service area. Tell us a little bit about that innovation and what challenges are involved with it. Oh, and one other thing, let's just step back. As engineers, we like to pick resistors and start with all the details. What is it you're really trying to achieve with this drop-in control house, or DICE as you all like to call it?
Yeah, so we started this project with trying to solve a problem that we have with at Dominion Energy. We have a large number of substations that we need to build with the expansion of solar integration and also data centers. We're building, historically, we've built about 15 new substations a year. And now we're being projected to build 40 to 60 new substations a year. So with all of our construction resources already constrained, we had to come up with a way to speed up construction. So one idea that some folks had was, well, if we could get all the panels installed into the control enclosure ahead of time, then we could take that control enclosure and just drop it at the station, turnkey, hook up some wires, do a little commissioning, and you're good to go.
What kind of construction time improvement were you looking at? If you did it a traditional way, I guess a stick built maybe is the way you did it before, and now you have your die solution. Is it days? Is it months? Is it hours?
Right now, we're estimating it'll probably save us about 4 weeks of construction time on a substation.
So that's pretty big.
It is.
Right.
And also with this new design, which we might get into later, it also simplifies the panel build. So where a traditional copper wire panel is, I believe it takes, for each panel, it's about 40 to 60 hours to wire. Now you're looking at, you can do all the panels in 40 to 60 hours.
That's interesting, right? And then maybe from our side of the business, when we would quote you a panel job, the way we would do that is how many connections are there? Right. And that's so if you can reduce those number of connections, it reduces your cost, it reduces our cost also.
Right. So with this new 61850 system, we're replacing all the copper wires that are copper control wires coming into the control enclosure with fiber optics. So we did our first design, which was a 4-breaker transmission ring. And there are 340 number 10 copper wires for a traditional substation. And now we're replacing that with 4 fiber optic bundles.
Let's talk about that. So we talked about your drop-in control house. That's pretty cool because you're going to do it off-site in a controlled environment. You can test and get it all ready to ship out to site. And you're also implementing IEC 61850 as part of the panel design or the relay design or protection design. Mm-hmm. For those, we probably have a handful of listeners that are not necessarily familiar with IEC 61850. Could you describe from the Dominion perspective and why you're choosing that particular technology to implement in your dice enclosures?
Sure. So IEC 61850 is an international communication standard where you're converting your traditional analog signals, currents, voltages, or other contact statuses to a digital format. And then so that digital format gets sent to a centralized server network inside the control enclosure, and then each device, protection device, control device, can subscribe to any data points that it needs. So we chose to go with 61850 because it allows you to condense the amount of protection and switching and controls on the control enclosure panels.
What we end up doing is taking the things that touch physical equipment, whether it's the current transformers, the voltage transformers, the contacts, the 52A and say a circuit breaker, taking all those measurement points and actually getting them as close to wherever they reside in the substation as possible. So putting a merging unit, if you will, next to the circuit breaker to measure currents and voltages, and then using fiber optics to bring in that digitization of the current measurement or the voltage measurement back into the control house, which is pretty cool because you can make the control house much smaller now because I don't have all the copper and wiring and half the relays, is out in the substation now.
Right. So in a traditional 4-breaker ring station, just the protection panels, we're using 8 panels.
In your traditional design?
In traditional. Okay. So we've got 1 panel per relay, 1 panel per breaker, and then 1 panel per transmission line. Now we can condense those 8 panels down to 2.
How does that work for your technicians that are in there? Because it's pretty easy to go, that panels were, dedicated to that circuit breaker and that panel's dedicated to the line. Because you probably could have condensed more stuff. Maybe it was from human factors or something. You could design those.
Yeah, so historically with the copper wiring traditional substation layout, everything was broken up into individual components for the human performance aspect of it to really help the technicians understand, all right, I'm on this panel for this breaker, I got to turn this handle. So, but with this new condensation of panels, we have removed all of the physical switches, breaker control switches, reclosing, anything like that. It has now been removed from the panel, and all the switching is done with a HMI or human machine interface. So we now have a touch screen, actually dual touch screens for redundancy, and all of the switching and alarms and everything is done from that touchscreen HMI instead of doing actual switching on the panel.
That's great. I'm sure we've got a lot of folks that are considering 850 solutions. Dominion really is one of the first utilities to develop standards that, in their designs for 61850 based substations, certainly as I said, in the US. And you all have gone, I think, from the design phase, what you think it should look like, into the lab phase where you can have your engineers test stuff. And I think you're into the, I don't want to call it field testing right now, but you have a mock-up, if you will, at your test center where you can bring in technicians. What have you learned from those various phases of from design to labs to field testing that you've learned, maybe you were surprised with, and maybe some of our listeners could benefit from your experience?
Sure. Yeah. So it's been quite a journey. We started. We kicked this project off about May of 22, and we're now at the point where we're building our very first DICE enclosure at our System Protection Training Center. So that, one, it helps us kind of vet out some of the construction aspects of it, which we're already finding some issues, which is great, before we actually get it out to a substation. And it's also going to allow us to train all of our personnel, all of our relay technicians. We're actually kicking off a class, I believe in May, to extensive 61850 type training so they know how to load the settings, work with the network, interrogate the relays, and do any sort of operations and maintenance there. Along the way, we've had lots of challenges, but we had lots of opportunities to do new things. So where historically we've, especially for our ring bus type station, we had separated breaker failure and reclosing functions in different devices. We're now able to roll all those into our line relays, the SCL 411L, which also helped us condense the number of relays that we need on the panels. We learned quite a bit. So we went through many iterations of design. That was actually a learning experience in and of itself. We thought, we would just kind of go through the motions and the cake is going to come out the other end. But sitting down and actually stepping through all the different use cases and pulling all those threads, and sometimes they're interconnected and you didn't realize it. So a decision over here is really going to make an impact over there. So working through all that was quite a challenge. I would say for folks going down this path for the first time, something that we did from the very beginning, and I definitely advise it for anyone starting this, is get everyone in your organization involved. So whether it's different, your system protection folks, your field folks, your system operations folks, switching, your maintenance folks, your laboratory folks, get them all involved, get them to the table. They have lots of inputs and insights there.
I was going to ask you, it's the engineers, whatever the greatest new technology is, they're just going to fall in love with it, and they're going to have a great time. Some of the challenges or concerns I've heard with the implementation of 61850 is not necessarily the objection, but the challenges it represents for the field folks, the relay technicians, because it is different. They used to be able to get a DMM and ring out a connection. It was pretty easy to troubleshoot once you're in the field. And now we're digitizing all this stuff. So it's a new paradigm. Even testing the system. If you have a merging unit out in the field, do you inject currents and voltages out there? And you got another person now inside the control house saying, oh yeah, the metering is right and the polarity is all right on the phasing and whatnot. And I'm just curious, how have your field staff or the people that have to actually use the system day in and day out embraced or perhaps not even embraced the system? Maybe they're dragging their feet a little bit.
Generally, they've embraced it. We have our relay technician laboratory folks who are trained field technicians, and they've helped get us through this process. So it is, like you said, new ways of testing and commissioning these systems. So yeah, first you're going to inject your currents out of the merging unit with analog signals to make sure you're getting the actual values coming out on the digital end. And once you kind of prove everything out of the merging unit, then you can come into the house and with a new test sets that can inject sampled values, then now you're
on the network, not
right.
They're digital injection, not analog injection.
Correct. So once you've proved that the analog to digital conversion works and is getting to the network, then you can go in the house and set up your test set to inject the digital signal there, so you don't have to have people going back and forth. as much.
What about now that we're digitizing stuff, it's getting onto a network, and probably you have a couple different networks. You probably have a process bus, and then you have a network for Goose that's on there. Any cyber concerns about that?
With the new SDN switches that we're using, it's denial by default. So it's programmed to only allow the signals that you tell it to allow. So it's not an open source in that nature. So very secure. We're actually going to do some additional testing on that to see if we can hack it or break it.
Are you going to have pen testers come in and?
Yeah, we are. We're going to have our internal cybersecurity folks try to hack in. We don't think they can do it, but we'll see. We might have to let them in a few of the back doors. But
yeah. Oh, you don't have back doors, right? Please don't tell me you have back doors.
No.
You're going to open up a port for them to let them get in.
Right, exactly.
There you go.
Right, that's what I meant.
I know you did. Yeah. So we've talked a lot about let's say the internal benefits for Dominion. One is the dice structure allows you to do a lot of the construction, in a nice controlled environment, test out everything before you ship it out to the field. With the 61850 systems, I got to believe now you have really standardized templates for how you're going to design a substation, so you can just cookie cutter those throughout the enclosures that you're building. And those are awesome, and I love those, but they're what I would refer to as an internal focus on Dominion. What are the benefits for Dominion? How do you see this benefiting your customers, whether it's, the data centers or the integration of renewables or maybe even the ratepayers?
Yeah, so it has a couple different benefits to it. So with us able to speed up construction, one, it helps us get those either solar interconnections or data centers interconnected, energized faster. Also helps us just with labor costs as well. We'll be able to get that done in a more cost-effective way, which again helps our ratepayers in the long run.
If you could give advice to other utilities, you said bring everybody to the table, or bring everybody to the table. Who would you bring to the table first? Is it management? Is it the engineers? Is it the construction or the people that have to maintain the systems?
Yeah, I mean, first you have to have upper leadership approval, or they're maybe the ones who are driving.
And you're pretty fortunate at Dominion with some forward-looking Matt and everybody else out there.
Yeah, we have some fantastic leadership, and they gave us the green light and said, go get it done. So that really was great. I've talked to some other utilities, and that's not the case all the time. So we were very fortunate in that respect. So yeah, certainly getting management buy-in really helps get that first part of the process going, gets the organization headed in the right direction. And then still you need somebody to organize it and get everybody to the table, get it all kicked off. And, going into it, there's still a lot of things you don't know. You don't know what you don't know sometimes. So there were definitely some exploration there. And so I guess I'd also say most utilities are not going to have the expertise in-house. So you're going to have to bring in a vendor, third-party consultant or something to kind of help you step through these things. Otherwise, it's going to take you a long time to chew through all the different facets of the new 61850 system.
That, I think, is really, really important. Phil, let's talk a little bit more about the DICE integration bay and what you're doing there, and perhaps how others could benefit from it.
Sure. So we already have internally, we have one panel wiring shop, and we're building a second panel wiring shop to help meet the demand of all our projects that we need to build. So in addition to that new panel wiring shop, we are on the end of it building what we're calling a DICE integration bay, where we're going to be able to bring in our empty control enclosures, take the panels that we're building, integrate them all into the building, do all your commissioning checks and testing and everything there in a controlled environment. And then from there, we'll be able to take it and drop it at the substation site, and then do the final hookup of the external fibers and the power source, and that'll help us control our product that we're getting out there. the product will also be closer to the substations that we're installing. So, there's some other vendors out there that do this kind of work, but they're out of state. We'd be shipping these enclosures a little further. So, Dominion does like to be a little vertically integrated when they can. So, this is just one way for us to help control our own product, our own quality.
Yeah, I'm impressed with what you're. It's the repeatability as a manager anyway that would get me excited, right? As opposed to every substation being this one-off. We're the prince because it's going to be different than the last substation I was in. You can just cookie cutters like we like to say, and just do it over and over and over again. And you'll save time, money, quality will increase.
Right.
And when you walk into a substation, you know exactly how everything is supposed to work. That's tremendous benefits. So
that's something else to circle back to one of your previous questions, advice for other utilities. So we've seen, we're not the first ones to use 61850 in the utility space. I know some utilities have kind of done pilots where they'll install it first and then kind of see how it works and then maybe make a standard from there, where we started from the very beginning with creating the standard, working through all the wrinkles there, and then we're going to deploy it. So we're really trying to work out all the issues before it gets deployed instead of seeing what happens once we install it in the field.
Yeah, that's great. You're still working on the design for your DICE. Where do you see DICE evolving to? Maybe data centers, other applications for it?
Yeah, so our first design was for a generation interconnect station, a 3 or 4 breaker transmission ring. We wanted to do something simple, but with all the data center projects that we have coming down the road, we're also going to start looking at our next design, which will be a full T&D substation. A typical data center station is going to be, a 6-breaker ring with 5 step-down transformers and 20, 30 circuits coming out of there. So that will be our forward-looking goal to get that done, and then kind of feed that into the hopper to use that in the DICE integration bay and be able to support all those large number of projects coming down the road.
Does DICE help? And I don't know what kind of lineup your primary equipment lineup you're doing at the data centers necessarily. I don't know if it's just traditional, open air stuff or GIS or whatever. But how does DICE help shrink the footprint then of what you need inside a substation, especially if you're constrained in Northern Virginia? I got to believe land is pretty expensive there.
It is. We're seeing, I believe last numbers I saw, land up there for substations was running $5 to $7 million an acre.
Oh my goodness.
What's great with the DICE, a typical 4-breaker ring copper substation control enclosure was a 24 by 50 foot control enclosure.
Okay.
With a DICE product, we can shrink that down to a 12-foot by 50-foot building. So it's more of a single wide instead of a double wide. We can shrink that space there. And then we, with certain substation designs, we use air insulated, but when it's really tight, we will switch that over to gas insulated substation or GIS. That allows us to really condense the substation footprint.
I just mentioned I'm a manager. One of my jobs is to manage risk, and I'm wondering if you guys thought about, all right, let's say we go down this road and we get to a point where it is just not gonna work. Did you ever have a plan B, a backup with if the DICE or 61850 just you hit a roadblock you just couldn't overcome?
Yes. So we've talked about it. So far, we haven't hit any of those roadblocks. We've done extensive lab testing. We've done RTDS testing. We've done testing for months on end, continuously to see if there's any failures in the system. So, I'm glad we did, because you find little issues here and there. It's just like, oh yeah, we need to change this setting or do this thing, do that thing, to resolve it. But no, so far we've seen great results from our extensive testing. So we're pretty confident it'll work in the field. So, but if something were to go really sideways and it not work, then we would definitely have to pivot and then probably switch back to a copper solution of some sort. But that would be a last resort, I think.
Yeah. And it seems like with your approach for it, it's been very measured and very, I don't know, well thought out, maybe is the best way to describe it. And you're bringing along the various from management to the engineers to the field folks, probably your contractors too, right? Bringing everybody along to make this success. And sounds like it's very measured, right? You're not in a rush. You want to get it done, it sounds like, but we got to do the right things first. There's not like this hard date that everybody has to magically meet or something.
Right. Yeah. So we are trying to get it done right the first time. So we're not trying to just rush it and get it out the door. We do want to get it done with all the projects coming down the road, but we do want to make sure that we get it right the first time, so we don't have a major issue. Get a black eye per se.
Yeah, exactly.
Takes installing a new station. So
that would crush the effort, I think, if you got that first black eye. Somebody will go, "I told you so," right? And trying to recover from those is pretty tough.
Yeah, so we're really trying to cover all our bases there and make sure we've done it right before we deploy the first one.
Well, I know that talking to our folks, I've seen your labs. I've seen how our folks have been helping you. It's very impressive. You guys are certainly doing a lot of great stuff. I can't wait, to see the first DICE system, 6150 system installed on Dominion's power system.
Yeah, we're pretty excited about it. We're looking forward to. Right now, we're probably thinking first field install is probably going to be somewhere in the late 26, early 27 range, as we kind of have to, so that's something else to consider is, even once you get your standard done, then once you release your standard, you got to release it to your design folks. And they've got an 18-month design cycle that they go through. So really, even if you're done today with your standard design, you feed that into the hopper, and then you got to find projects to get that applied to. And so you're looking at 18 months to 2 years really to get something built there. So,
well, that'll go into a substation that'll stand there for 50 or 60 years too. So it's once you start putting cement down and putting buildings on it, right, it's there for a long, long time.
That's right.
Well, Phil, thanks so much for taking the time and describing what you're doing out at Dominion. It's impressive. And again, I can't wait to see the system working out in a substation at some point.
All right, great. Thank you for having me.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.